Okay, first I want to test. I want to test for symmetry for like a regular function, like what we've done before. So going back, you guys can use this for on your study guides right now. But we're gonna apply this to a polar coordinates. So there's a negative x, and negative y, and a negative y. So here's all the different tests. Okay, so for the first test, I want you guys to think of a parabola. If you guys were to plug in an x and a negative x and a parabola, what do you get? You get the same thing. So an x and a negative x, you get the same y. You see, if you plug in an x and a negative x, you still get the same y value right there. Okay, so this shows us symmetry for this type of a function. Okay, so this is called y-axis of symmetry, but only if f of negative x equals f of x. I mean, those are two different y values. Well, they're the same y values actually. So like f of negative x would be that y value. F of x would be the same y value. So they're the same. For the negative x, negative y test, that would give you guys origin of symmetry. Okay. But I wanna simplify this a little bit more. I think this is pretty mathy language right here. Instead of saying that, I just want to say get the same. Like, are you getting the same thing is what you started with. So like when you plug in a negative x and a negative y, do you get the same? Because if you do get the same, then that means this one has symmetry about the origin. Okay, the symmetry about the origin is like an x to the third function. Now, when I do a negative y test, we are not testing for functions here. Okay, these two tests, they test for functions. This tests for an even function, this one tests for an odd function. When you do a negative y test, you're doing an x-axis of symmetry. Well, if a function has an x-axis of symmetry, it's not a function. So this right here would not pass the vertical line test. That's because every x value has a positive y and a negative y value for it. So this is not a function. But if you do a negative y test and it passes, you get the same thing that you started with, you get the same, then you know that you have symmetry about the x-axis. So let me give you guys an example here really quick. Here's a simple example right here. Y equals x squared plus 3. Some of you guys know what this guy looks like, but I want to do the test for each of these. If I plug in a negative x to the second power, negative times a negative is a positive, so you get x to the second power plus 3. Hey, did we get the same thing? Yes, that means this guy has symmetry about the y-axis. If I try the other test just for fun, I get negative y equals x squared plus 3. Is this the same thing as what we started with? No, so it's not. It doesn't pass. Okay, this one over here will also not pass. And so let me show you guys one that will pass. Okay, so let's try x squared plus y squared equals 5. Okay, let's try the first one. If I plug in negative x and I square it plus y squared equals 5. You guys know what kind of function this is, by the way? Circle. Yeah, you know it's a circle. If I plug the negative x into that, what do I get? X squared plus y squared equals 5. Do I get the same thing that I started with? Yeah, so does it have symmetry about the y-axis? Yes. Okay, if I plug in a negative x and a negative y, do I end up with the same thing? Yes, because a negative squared gives you the same thing. Oh, well, negative 1 squared, and then a negative y squared will give you the same thing. Do we even need to test the last one? So this one I have x squared, and I'm going to plug in a negative y. I square that down, and I end up getting the same thing. So this type of function, actually it's not a function, this type of equation has symmetry about all of these. Okay, so it has symmetry about the y-axis, the origin of symmetry, and it has x-axis of symmetry. So how does this look with polar equations?